So today we're going to be talking about expressions or mathematical expressions. Math is an area that I never excelled at in school. I only got through ninth grade algebra and barely at that. So um, I only know basic math and I only can really do basic stuff with expressions as a result. You are probably better at math than I am, but that being said, I have learned how to do a few things here with expressions in MegaZeux, so I will show you what I've learned, and then you will probably be able to go on to do much better things. So to create an expression, you just put some values inside parentheses, like so. So 5 plus 3, so this sets local to 8. This sets the counter banana, and uses a couple of other counters nested inside an expression. So this is adding the counter minion and the counter crazy and sets banana to that value. This takes the counter prints and sets it to the value of toad minus curse plus lick. So when, whoops, this isn't correct. I didn't test these first either, so I hope they're correct. So when you have more than one set of parentheses, the MegaZeux program will look at the innermost parentheses first. So it's going to take this expression and do what's inside these parentheses first, and then it will take the outer set of parentheses and then deal with that next. So when you're using counters inside of parentheses, you can either use single quote marks like this, or you can use ampersands like this. So your counters must always be inside of either of those, either single quotes or parentheses. That's how you are letting MegaZeux recognize that those are counter values. You can, when you're using symbols like this, like add and subtract, you can either put in spaces or not. That's up to you. You can do spaces, or you can do without spaces, and MegaZeux will take it either way. It doesn't matter. So your parentheses also have to be inside of quotation marks. Remember, the quotation marks are what you put a counter inside when you were using a counter to represent a value. So it would be the same if you were setting local to 8, then you just do that. But if you want to use a counter, you need to put it inside parentheses. And if you're going to use an expression, then you place that counter with parentheses, and then you would put your values and your operating symbols inside of the expression like this. So you can use symbols like add, subtract, multiply, divide, greater than, less than, equal to. You can also do other values like not equal, or greater than or equal to, or less than or equal to. You can do other comparative statements too, but I don't really know how to use those as well. Let's go and look at them for a second. So, addition, subtraction, multiplication, division, modulo, exponent, bit shift, greater than, less than, greater than or equal to, less than or equal to, not equal to, and then and, or, and, XOR. So this explains what they are. Hopefully you have a little bit of familiarity with these, because I don't know how to use but a few of them. I'll show you the ones that I know how to use. Okay, this is the main engine for my game servo. It's inside the global robot, and it's a pretty large program because it does a lot of different things. There are expressions throughout this program, and although the program is 1,980 lines large, it would be double or triple that, and it would easily be larger in size than MegaZeux would allow if it weren't for expressions, because expressions can do many things in one line, things that it would take many lines otherwise to accomplish. So in this one expression right here, this is asking if this is basically checking for button presses. So if the action button equals 1 and the up button equals 0 and the hover ability is greater than 0 and the rocket ability equals 0 and the roll ability equals 0 and the falling or the condition of falling equals 0 and the condition of jumping equals 0 and the left button equals 1 or the right button equals 1, then go to the label top 2, otherwise don't. So this one expression is 192 characters long. Expressions can get pretty large sometimes. You can make an expression as long as allows a line to be, and a line can be 241 characters long. So that is the maximum length that an expression can get, because 241 characters is all that MegaZeux will allow. But you can see that this is a pretty large expression right here, and it's only 192 characters long. So you probably will not run out of space making your expressions. And if you do, you can just split it up into 2 parts and have the rest on a second line. That's not too difficult to do. So this is a this is an expression that is testing for a bunch of different conditions at once. And if I was to check for all these conditions individually, it would be, a dozen lines long, but it does it all in one line, which is just beautiful. This is also an expression here. If roll equals 1 and the ability to roll equals 0, then go to the label unroll. This is another expression here. If the ability to fall is greater than 0 and the condition of falling is greater than 9, then go to shoot, the label shoot. So these are all expressions. So expressions cannot just add, subtract, multiply, and divide values, but they can compare values as well. And when they compare values, they output a value of either 0 or 1. What this essentially is doing, this line here is taking the counter character and it's flipping it back and forth between a value of 3 and 4. So if the value is 3, it changes it to 4, and if the value is 4, it changes it back to 3 again, and I'll show you how it does that. So when you use this, if you just look at this part of the program right here, so character less than or equal to 3. You get one of 2 outputs from that. You get either 0 or 1. So basically you can take this part of this expression and just whittle it down to 2 numbers, 0 or 1. If character is less than or equal to 3, it outputs 1. And if character is not less than or equal to 3, it outputs 0. And then it takes those 2 numbers, either 0 or 1, in the second half of the program. Okay, so I can take out, so for the purpose of this example here, I'm going to take out that upper part of the expression. Okay, so let's suppose that character equals 3. So if character equals 3, then the value of this part of the expression is 1. It multiplies 1 by 4 in the next part of the example. and the answer to 1 times 4 is 4. And it adds that to the next part of the statement here. The next part of the statement is character greater than or equal to 4? Well, we've already determined from the previous part of the expression that character is equal to 3. So in this instance, character equals 3. It is not greater than or equal to 4. So the answer is 0. So it multiplies 3 by 0. The answer to that is 0. So essentially what you're doing is adding 4 plus 0, which gives you an answer of 4. So it is setting character to 4 when character equals 3. Now, if character equaled 4, what you would have would be over here on this side, you would get an answer of 0. So it would multiply 4 times 0 and give you 0. And over here, it would output 1. So it would multiply 3 by 1 and give you 3. So in this example, if character equaled 4, you would be adding 0 plus 3 and output 3. So if character equaled 4, it would change it to 3. So that is how the expression is used to just change the value of character just between 3 and 4. So if I was going to try and do what this expression does without using an expression, I would have to use 1, 2, 3, 4, 5, 6 lines of code to do what this expression does in one line. So what these lines do is they say if character equals 4, then go to the label 3. Whoops, typo. You come down here to the label 3 and it sets the character to 3 and then goes on. So if character equaled 3, then it wouldn't jump down to that label and it would set character to 4. And then would go to the label continue, would jump down here, and it would continue on. This line is an example of using OR statements in an expression. So this is looking at the counter falling. So if falling equals 1, or, that's the O here, if falling equals 2, or falling equals 4, if that statement is true, then it goes to the label top 2, otherwise it goes on. So this works the same way that the greater than and less than symbols do, and it outputs a value of 1 in this place. So if this part of the expression equals 1, or if this part of the expression equals 1, or if this part of the expression equals 1, then this statement is true because the expression equals 1. So it only has to have one part of the expression be equal to the value of 1 in order to be true. So that's how the OR statements work. AND statements work the same way, but if you were to have A's here, that would turn these into AND statements, and each part of this expression would have to be equal to 1 in order for the whole expression to be equal to 1. If any part of this expression was not equal to 1, then it would equal 0, and it would not go to the label top 2 because it wouldn't be true. And of course, in this example, you have the same counter shown 3 different times, so this statement could not ever possibly be true. You would have to have a different counter in each of these spots because a counter can't equal different values at once. So if you wanted to have a counter continuously run through the first 6 digits, 1 through 6, and reset, you could do it this way, or you could do it this way using this expression and do it in one line instead of 1, 2, 3, 4, 5 lines. So this expression here sets character. If character is less than or equal to 1, it sets it to 2. If character is equal to 2, it sets it to 3. If it's 3, it sets it to 4. If it's 4, it sets it to 5. If it's 5, it sets it to 6. And if it's greater than or equal to 6, it sets it back to 1. So in one line, it's increasing the character counter every time it comes past this line, and when it reaches 6, it sets it back to 1 again. And I could do this in reverse too. I could have it go from 6 back down to 1, and then reset itself back to 6 when it reached 1. So even with just a real basic understanding of math, I was able to have expressions help me do this complicated program where my program draws this line on the screen for me to simulate a laser beam. Just with a couple of expressions, I'm able to achieve that program that draws the line on the screen. So really anything's possible. This program here I did not write. It's a program in my game that simulates an arch. I use it when Servo is throwing things like bombs or crates. And this was written for me by a fellow MegaZeuxer, Alexis. And she was kind enough to write this program for me after I expressed a need for help on the forums. And I can't explain to you how it works. I only know what it does. So some of you may understand it from looking at it. There's more to it than that. There's some initialization of the actual program up here. But basically this part of the program here, this is the guts of the program. And what it does is this. If I pick up this crate, it creates this arch. One point I want to add is that when you are debugging your program, say you have an expression that's not working, you should count the number of right-facing parentheses in your entire expression, and then count the number of left-facing parentheses in your entire expression, and make sure that you have the same amount, because if you left out a parenthesis, that would be different. And you should always have the same amount of right and left-facing parentheses, because all expressions always have to be enclosed inside parentheses, and so if you are nesting expressions within expressions and your program is not working right, it's possible you left out a parenthesis somewhere. Okay, one last thing I wanted to draw your attention to was over at digitalmegazeux.net and the MZX wiki. If you head over to the MegaZeux section of that wiki and look under expressions, there is a very good explanation of expressions there, with even a tutorial style example along with really great definitions of what all of the things you can do with expressions are. And this was where I first learned how to utilize the comparative properties of expressions, and the fact that when you compare two parts of an expression, it outputs either 0 or 1, and that you could use that to set a counter to different values. I know this tutorial just scratches the surface of what you can do with expressions in MegaZeux. If I was better at math, I could explain a lot more, but this should at least get you started and get you on the right path towards being able to make some really cool programs of your own. Thanks. Bye.